My name is Dimitris Hadjiorgiou, and I work at the Student Success Unit, or SSU, which is part of the University College. Okay. Please, if I talk too quickly, do let me know, because sometimes I get a bit excited about the subject matter. Okay. So, essentially, these are the main parts or topics that we'll be looking at this morning. Some Python downloading, installing packages, etc. Special characters, data types, and I've actually moved this part 4 with part 1. Then some control structures used in programming, arrays, mainly using NumPy, writing functions, recursive functions, lambda, as you can see on this slide. And we finish off with sort of introduction to a GUI, which is a graphical user interface. So hopefully by the end of this session, you'll be able to install packages Python, use if, while, and for statements, write your own functions and use functions, read and write to an Excel file, create some simple graphics using the turtle and matplotlib, and create a very simple GUI using tkinter. Now, please, at the end of the workshop, can you make sure that you fill in this form, evaluation form? Now, the link I will put into the chat. That's the link to the evaluation form. This is asked by the College of Graduate Studies, and I will put the link at the end of the presentation as a reminder. So what is Python? Essentially, Python is an open source programming language as opposed to things like machine code or assembler. And what this means, in a high-level programming language, you write code statements like this, which are fairly understandable by human beings. Unfortunately, computers understand machine code, which is essentially a sequence of zeros and ones, which is not really easily understood by a human being. And in fact, I think this particular operation, I'm actually adding two numbers together, but it's not clearly obvious to anybody that this is what this bit of machine code is doing. And the next level up to machine code was assembler, where we got words or parts of words like move, AL, 61H, which is hexadecimal representation of the decimal number 97. But the machine code is really what computers understand, and we have to change our high-level language into their language so they can actually perform the tasks that we ask them to do. It runs on Windows, Mac, Linux, and Unix, and some other operating systems. It's an interpreted programming language as opposed to compile. And if you look at this graphic here, you'll see there's an interpreting process here to what's called the virtual machine and machine code. Whereas a compiled language like C, C++, for example, you're missing this extra step, if you like. So from your high-level language, you compile it and it turns it immediately into machine code. So interpreted languages tend to run a bit slower than compiled languages. So you've got to be aware of that. It's also a case-sensitive programming language. So if you designate a variable name as lowercase aa, Python, if you at a later part of your program were to type uppercase AA, it would recognize these two items as separate variables. Okay, so yeah, again, you've got to be it's case sensitive. And similarly, if you use any of Python's keywords or functions, if you like, you've got to be careful with the case sensitivity of that particular name. It's also an object-oriented programming language, which has a lot of advantages as a programming language. Now, again, this is where you download Python, and there's a whole host of what I call code editors that you can use. Some are free, some are community versions, which have limitations on full functionality. And really, my best advice is have a look at some of the more popular ones, which are like PyCharm, for example, Anaconda, Atom, Visual Studio Code, Code Runner, again for a Mac or Sublime, and depending on, I said, if you've got a Mac or a PC, and see which one you like. That's the best advice I can give you. Personally, I use Visual Studio Code because it's free, and you can write in about 20, 30 different programming languages and save the files in that particular format. Now, the real power of Python is the packages that you can actually install. And what happens is, these are some of the more popular packages. Pulp, if you're into linear programming, algorithms using NumPy, as you can read from here. Now, about 18 months ago, I had a look to see, and there were over 4,000 packages that you could actually install into your Python environment. So, as I said, you usually find a package that does your particular job or has functions, if you like, that will do a lot of the things that you may want to do. Now, the packages that you should really download and install, not download that, really, yeah, you download it and install. Pandas for data analysis, Matplotlib for which is part of the data visualization, NumPy for dealing with multi-dimensional arrays, SciPy, scikit-learn, Open PyXL, Control, and SymPy. So these really you should install. Now, to install a package, you either use pip or conda, depending on your environment. And essentially, this is Visual Studio. So this area here that I'm highlighting is my program. This is the sort of folders, if you like, that I'm using and files I'm using in my programming environment, if you like, code editor. And this here, as you can see, is the terminal. So if I wanted to install something, I will basically go to my terminal window, type in pip install, and then I'll just put pandas, which I've already installed. So press enter, and then it'll go away and start looking at various repositories. And it says the requirement is already satisfied. It actually checks my installation. It says, okay, you've already installed it. Now, if you haven't installed it, then isn't that good? Oh. So is no, that's a blow. Not sure what I can do. Is this better now? The PowerPoint? Is this better using the PowerPoint instead of the code editor? Okay, so, oh, I'm not sure what I can do about that. Okay, we'll, there must be some technical issues somewhere in the ether. All right. And again, this is a very useful command here at the bottom, pip freeze. And what this does, it checks all the packages in your Python that you've installed, and it will automatically, if you like, update your package installations with the latest versions, rather than doing it manually, which can take quite a long time. So first of all, with what is an algorithm? What's a variable? So what is an algorithm? Essentially, an algorithm is a set of steps to solve a particular problem. And for example, you could, if I was, for example, if you had a very smart robot, you could write an algorithm for the robot to essentially boil an egg for you. And that would be what an algorithm is, just a set of instructions, if you like, or steps to solve a particular problem. And a variable, now a variable is a name that refers to a location in your computer's memory, essentially RAM, most likely. And variable names in Python have to begin with a letter. They can be alphanumeric, or have an underscore character or characters in them. But no spaces are allowed in variable names. Okay, so that's what a variable is. And if you look at this graphic here, essentially the name of the variable is age. The location, the little yellow box, is somewhere in RAM, and 18 is the actual value that's been assigned to the variable age. That's the idea of what a variable is. Again, variable names are case sensitive. And again, as a programmer, you should always choose a meaningful name for a variable, because it helps you and also helps other people understand what is happening in the program. Okay. And again, you should have an idea of reserved words that have a special meaning in the Python language. Words like if, for, else, while, true, false, etc. And you shouldn't really use these, if you like, reserved words for any other use than what they are actually intended by the programming language itself. And here are some examples of variables. So players equals 11, subs equals 5, warning underscore message 1 equals foul. And as you know, if I were to ask you from those variable names, what is the program that I'm writing about? Can anybody guess what this program is about that I'm writing? Purely from the variable names.
Football club.
Sorry?
Football?
Yeah, exactly, football. And this is what I mean by choosing a meaningful name for a variable. It becomes easy for people to look at your code and say, oh, okay, I've got a rough idea of what is happening in the program just by looking at what the program is about, purely by looking at the variable names. So again, special characters in Python. Python does have quite a few special characters. Now, the most useful one for me is the Hasp, which is this symbol here. And let me just put my pen on there. So this is the Hasp. And essentially it's used for designating comments in your code. And the comment, this is essentially a comment here. Comments can be on individual lines, as shown here, and it's telling me that the following line of code is initializing the variable x. And somewhere above this, there will be another comment telling me what x actually stands for, or what it represents in my program. Now here, in this example, y, there is a space here, and you've got the Hasp symbol, and this is essentially in your line of code, you've actually added a comment. So this is in a code line comments, and these are basically in their own individual lines of comments. So it's very important to comment your programs from the beginning and get into the habit of doing that, adding comments. Now the backslash is another interesting special character, and what it does is it tells Python to continue, that the line of code continues on the next line. So it's what it's saying, this backslash here is saying, okay, this is also a continuation of this code line. Now this is a trivial example, but what you may see here is, sorry about that. If you've got a big chunk of code that you want to, where are we? Here we are. You could actually have backslashes here to continue saying that this continues on the next line. So that is a more practical use. And sometimes where this, again, becomes very useful is if you have, or if you're using a function that takes a lot of parameters, or arguments, if you like, you can actually get quite long lines of code which are visually hard to look at in your code editor, and you're scrolling from left and right. And by using the backslash, you can actually condense that long line of code over 3 or 4 lines and make it easier to look at in one go. Now, Python is what's called a loosely typed programming language. And what this means is that you don't need to necessarily define a variable before actually using it in a line of code. And also in Python, by the actual type of data that you assign to that particular variable, Python knows what the variable type is. So in this particular case, num age, it knows that this is a real number, or a float, as it's called in the programming language. Here, where you've got two, the number of kids, if you like, is a whole number. You can't have 2.5 kids. And it knows that num kids is an integer type of data. Similarly, first underscore name, because of these quotation marks, it knows that this is a string. So the data type of first underscore name is a string. And here, again, purely because of this value, and notice the uppercase F, it knows that this is what's called a Boolean type of data. Now, Boolean type of data have 2 values, true or false. And again, this is how to assign a variable either the value of false or true. And again, the first letter of false and true must be uppercase, otherwise your program will flag up an error. Okay. Again, you've got integers, so signed integers, as you can see here, floating point numbers, and you can use the E notation, which is essentially what this is here. Complex numbers. And you also have functions to change a particular number to another type. So whatever x is, it will change it into an integer, and it will round down, if you like. Whatever x is, it will change it to a float. Similar if you use the complex function x with only one argument, essentially. It assumes that the imaginary part of that complex number is 0, and if you have 2 arguments to the complex function, it will give you the real and the imaginary part of that number. And here we've got so both I can be used. Well, let's have a look at this. Can you use I? Let's have a look. Can you use I? This is a real number. If I type I, oops, sorry, I for D there, run. And you can see it comes up with a invalid syntax. It doesn't like I. If I put it back to J, run my program, again, it essentially creates, it runs, and here is the complex number D as well. So the answer to your question is no, you can't use I. It has to be J, and it can be uppercase J or lowercase J. So again, here this is again an example of what I meant by using the backslash. Okay, in a program. So what you have, in fact, this is the function plot. And it's actually spread over 1, 2, 3, 4 lines, if you like, rather than one single line, which would be horrendously long. And if you wanted to look at the various parameters of it, you'd be, I said, scrolling left and right on your screen. So here, just to have explain what's happening in this program, here I'm actually importing packages or importing particular modules, if you like, from that package or functions from that package. This is print hello world, which is the first bit of code. And again, here, hello backslash world. I've actually spread this line of code over 2 lines. And as you can see here, in my, so this is hello world from this statement here, hello world, which is from these 2 lines of code, and then boo. And this particular bit of code here, what it does, if I run it again, it produces a graphic like this, which you can add annotation to it, etc., and do all sorts of other things to it. And all it is really I've taken X and Y, a set of random points from it, if you like, and I'm using this particular, if you like, module random from the package NumPy to generate the random numbers, and then the various other parameters here change the colors, line styles, etc., etc. So here now I have a floating point number, which is changed to 5. It's essentially rounded it down, as you can see here. Then this 3/4 is 0.75, Then we have the complex numbers here. A few more complex numbers. Then this is obviously division. And here the twin asterisks are actually taking the power 2 to the power of 3, which gives us 8, as you can see. And then 2 to the power of 0.5 is essentially the square root of 2, which is 1.414, etc. And here I'm just printing these plus signs. And then we get to this particular operation, the modulus operation. And as you can see, the result is 1, 2, 3, 0, 0. And then we get to the forward slash, which is essentially what you have here. It's a divide, but integral, an integral result, and it tends to round down to negative infinity. So you can essentially, as I said, use the asterisk here, forward slash, the plus sign, minus sign, the 2 asterisks to denote an exponent, the modulus, which is the percentage sign, and the forward slash or rights, 2 right slashes or 2 forward slashes, which is, if you like, division, but integral result. So that's the type of simple math operation that you can do. Similarly, you've got strings. Now, in some languages, they have a particular data type called a char, which is 1 character. Now, in Python, they said, look, really, a char is a string of 1 character, which makes sense. And to assign strings, you can use single quotations or double quotation marks, and enclose the string in between those marks. And again, here, this is a space, as you can see, which I've just underscored here, and that obviously counts as a character. Here I'm assigning a variable a to the string hello, and just printing out hello. Now, strings can be regarded as arrays, and each, if you like, element in the array holds a particular character. And because of that feature, you can actually designate a particular character, or in this case, print a particular character in the string that you want to actually have. And so if I were to have hello, for example, here, the third character would be, the first place has an index of 0, 1, 2, 3. So it would actually print out this particular character. A of 3, this is a string, this is the first position, 0, 1, 2, 3. But again, something that is, as you'll see, it doesn't actually print the third, it prints 3 minus 1, so it actually prints out this character. Now, you've got to get used to the fact that if you have a range of values here, it'll actually print the nth minus 1 character of your array. You can also have chunks of text enclosed by 3 single quotation marks, and when you print, for example, my Latin out using the print function, it will print it out as you see it on the screen there. So you can also do that using the 3 quotation marks. So if you want to find out how many characters you have in a string, you use the len function like this, and which is, here we go. print my Latin. This is print hello world. So here, for example, I could have print len c, and the answer would be, let's have a look at what it would be. Print less. Anybody care to have a guess what the answer might be? Print len c. What the answer would be? What do you think?
3.
3. Well, you've got A, okay, which has 1, 2, 3, 4, 5 characters, okay. You have B, which has 1, 2, 3, 4, 5 characters. So in C, you are essentially concatenating A and B. So you've got 5 characters plus 5 characters, which gives you 10. And here, you've got some spaces, 1, 2, 3, 4 spaces. So it might be more than 10. So let's have a look. Let's make it easy to see. So I'm just going to run the program again quickly. And if I look here, len c, it's actually 14 characters. As I said, we've got the 5 characters of hello, the 5 characters of world, and the in between them, 1, 2, 3, 4 spaces, giving us a total of 14 characters. Okay. So that's it. Again, you can do. Oh, sorry. So that's essentially what we've done there. And again, you can, as you've just seen, the plus sign when it comes to strings is the concatenation operator, which really means just sticking strings together. Okay. And here again, I am looking at the 5th character, perhaps. So let's have a look at this wording. So it actually gives us hello world. So in my program here, I'm going to go print. Just a comment. And print C. So we'll see what the 5th, what this actually tells us it is. So if I go run again. So we're looking for C square brackets, 5, and it says, oh, it's giving us the whole thing. Which, and then what does, let's have a look, SS, print SS, yeah. And here, sorry, yeah, I know exactly what I've done because I didn't put 5 there. Okay, there we are. So my apologies for that. Right, I got mentally distracted. There we go. So yeah, it should give us whatever 5 is, and it's saying it's actually a blank character. So if I change that to C2, and here C2, it's basically giving us an L here, which is 0, 1, 2, which is this character. And similarly with strings, you can do what's called, you can select ranges using this double notation here. and create different results. Then we have a mixture of functionality. We use the print, if you like, function, and we're actually feeding in several arguments to the print function. We're feeding this string age, the in operator, which is a special type of operator, as you'll see later, and then we're actually feeding this string called txt. And I'm not. Is the PowerPoint fine? Is that working in terms of the actual code screen? Oh, okay. That is interesting. Why it's doing that? I'm not sure what the solution is about this screen resolution. Anyway, continuing here. What this actually produces is the result true and GRUE, and what this will produce is the result false. Okay, false. And so what you're actually doing is by having this type of construct, code construct, using the you're searching for the string age in this piece of text, or text string if you like, and it will, this particular print statement will return a value of true or false, depending on whether it will find age or find the string mine. So again, this is where you can actually use the print as an object. And by feeding various parameters or arguments to that object, you're actually changing some of the functionality of the print statement. And here we have an interesting problem. That age, as I said, Python is smart enough; it realizes that its age is an integer, or it could be a float. And here we have a string, my age is, and I'm using this operation, and then the variable age. And what will tend to happen is that it will not like the result, because what you have is a string with, if I go back to this little program here, in fact, let me write do a new one. Do a quick new file. So if we've got this piece of code, we've got age equals 36, then tx. And then got now to run this with my code editor. I've got to save the file first, and then here, as you can see with Visual Studio Code, you can save your files in any of these various formats fairly easily. So now, once it's saved as a Python file, I can run it, and what it will do is it comes up with a type error, as you can see here, saying string not int to string can only concatenate a string to a string. So it's complaining about this. So to actually get around that, I would have to essentially use the str function, which is one of the main string functions, to change the number age into a string, and then I can run it, and lo and behold, it basically prints it down here. If I were to type in the text, it would print out my age is 36, which is what you'd expect it to do. So again, you've got to be careful when you're mixing types, especially if you're trying to concatenate numbers with strings. And here is another example of, again, using print, and one of the, if you like, methods or functions that are associated with strings, which is the count. And what this is actually doing, it's counting the number of spaces in this string. So what this would return is one space here, 1, 2, 3, 4, 5 spaces. So this would actually return a value of 5 because it's counting spaces. Similarly, you could change this character to E, and if I were to change this character to an E, it would give me 1, 2, 3, 4, 5, 6. It would return a value of 6 spaces in the result. So yeah, this is concatenation. So the plus sign has two functions essentially. As you said there, BJ, one is concatenation, when you are essentially sticking strings together, but when you are dealing with numbers, it is the mathematical addition operation of addition. So you've got to be careful when you are using the plus sign, okay, in strings, and you've got to realize you cannot concatenate strings with numbers. And again, you can, because if you like, a string is an array, you can print various slices, if you like, from your array using this sort of notation, things like this. So if this is my string here, you can then choose various types of inputs. So let me just choose the right file here, which is S1 string, which is this file here. So again, here, this is the example. And you'll notice this notation as well. I've got a plus sign, and immediately I've got a multiplication by 40. And what this does is actually create a string of 40 plus signs rather than typing in 40 symbols. So let me just click on run this particular file. And as you can see here, it's you've got this is the series of plus signs. Okay, this statement prints out the whole string. Here I'm taking it from the 10th to the nth, which is brown, and I'm doing various slices, if you like, using this particular notation, printing out various slices. Here I've actually reversed my string, as you can see. The quick brown fox, whatever. And again, here I'm using some methods replace. So it replaces the substring fox in this sense, in this particular my str, and it replaces it with box. So as you can see here, fox has been replaced by box. And again, using this title method, you can change the string to be this particular form. So you can do this type of stuff fairly easily, which brings us on to ranges. And a range, again, is it's interesting because it essentially gives us, sorry about that, it prints out a series of numbers, okay, and it stops before the specified number. So what this would do is print out the numbers from 0 to 9. And I've sort of jumped the gun here and used something called a for loop. And this is, if you like, a loop counter or a loop object, which looks into this range and prints out, it goes through the range in sequence, if you like, and prints out every item in that range up to the 10 minus 1 term. So if we look at this bit of code here now, let me just type it in quickly. So that's what I've got for K in range. K. So now if I go run, what should appear is 1 to 9, essentially. Oh, sorry, from 0 to 9. In my terminal window. So again, the range, you can consider it as a type of data object that holds numbers, for example. But it doesn't have to be numbers; it can be strings as well, or a string. And we also have in Python something called a list. Now, lists as such are ordered, and they are in the order that they are typed in. They are changeable, and they can have duplicate values. Okay, and they're also indexed. And this first item has an index of 0. Okay, so this is the first item here has an index of 0, 1, 2, 3, 4, and 5. Now, as you can see, I have numbers and strings, which is allowable, but if you are using some of the methods, if you like, that are available with lists, and you are using lists that have strings and numbers together, some of the operations may give surprising results or unexpected results. So do be careful with that. And again, if you want to find out the number of items in your list, you use the len method. And again, if you want to create another list, you use, again, the list, a constructor, if you like, in object-oriented programming jargon, or function, as I call it. Essentially, this is the format of the list here. So you created a new list using the list function or constructor, and inside the black brackets or parentheses, if you like, I have my new list, again, which contains strings and numbers, which is not necessarily a good idea, although it is allowable. You also have some things that you can do to lists, and these are some of the methods that are associated with lists that you have here. And if I just get up my file, my list file, which is CS1, which is lists, this one here. So I have a, again, list, you've got lists here, different types of lists. So you can sort the list, you can reverse lists, you can do various types of lists. And this is, again, in this particular file, cgs_s1 list1. So if you actually run it, what you'll get in your terminal window is an error, especially in this one here. Some errors in lists which contain alphanumeric data. So this is exactly what I said before. You've got to be careful if you're using lists that have alphanumeric data, because some of the functions will give you errors or unexpected results. So it's not a good idea to do that. You'll see here, for example, it's this was Z, okay, and it essentially reversed the order, Z reversed. But when I tried to reverse the order in my new list reverse, which contains alphanumeric data, it flags up a 0 because it's a combination of strings and ints. But you do have to be careful with that type of problem in there. And now, if you look at this diagram, you've got apples, and you've got sweet apples and apples used for tarts, which only become sweet after you cook them. And you've got a whole host of names here. And of course, you could have a sweetness index. So this could be 10, and here this could be 1. So you've got names and a sweetness index. And what you could do, you can actually create a structure, a data structure, using what's called a dictionary, where you essentially store a series of keys and values. And essentially a dictionary, it's ordered, it's changeable, but no duplicates are allowed. So essentially what you've got fruit type, which is an apple, because what you can do, you can actually, if you like, concatenate dictionaries together. So you could have another fruit type of orange, for example. And then you've got the name of it, you've got its color, it's got its sweet, tart factor. Now this I've called sweet, but you could say, you could either use words or you could have a number, depending on how you graded this this range of sweetness that you see in your data, if you like. And then what you can do again is print out all the keys in your dictionary, or all the values in your dictionary, or one specific set of combination of key value, if you like, and you've got some of these associated methods with dictionaries. So that's like creating a data structure for use with certain types of data, which can actually contain a lot of useful information, and then you can manipulate your dictionaries to get specific types of data from that. So that's really the data types that you have. There are, I think, a couple of more data types which I'm not going to mention right now. So now we come to the nitty-gritty, or the beginnings of the nitty-gritty. Keyboard user input, very useful. How do you get data into your computer, into your program? You use the keyboard. And one way is getting keyboard input into your program is using the input method. All right. Now, one particular problem with doing that is that you may well have problems with and this is the let me show you the problem that you have. What I've got is I've just printed a range here, okay, which I can actually comment out. We don't need to know about that. So this is one form of input, okay, using the input command, and here I've done something different. And you'll see why I've had to do something different. So if I run this program, you'll notice I've done the most recent transplant. I think there we go. Print *30. Let me just right. It says here enter number 2. So if I enter the number 2 in my terminal here, press enter. It says enter number 4. So I, being a good listener and reader, I enter the number 4, and it gives me the result 24. But is 2 plus 4 equal to 24? And the answer is no. Because what happens is input, as you can see here, read a string from the standard input and essentially outputs a string. Okay. So what it does here, this plus sign, because A and B are strings, it does a concatenation, a string concatenation. So it's changed the number 2 into a string, it's changed the number 4 that I typed into a string, and it's just essentially stuck the 2 strings together, and it gives me a result of 24. Now here, you'll notice I've wrapped my input function into the float, if you like, class or float function. So what that does, it changes my string input into a number. And similarly for B, the float changes it into a number. So here now, if I type in my terminal window, if I type 2, I type 4, it essentially gives me a value of 6, which is what I would expect. And the 0 here is because I've actually used a float rather than an int, the int function, to convert it to an integer. So I've changed my input, user input, to a floating point number. Okay, so that is how we can get essentially input from the keyboard into the program that we are writing. And now, one of the things, important things, is flow, controlling the flow of code execution in any programming language, not just Python. And what we do is we use the if else statement or if elif statement. So we've got a structure like this. So this is the, if you like, test that we are performing. Okay, and oh, sorry about that. Can you see the slide now? I think I swapped inadvertently the. Yep, good. Sorry about that. I inadvertently pressed on the wrong place. Let me just move that there. Okay. So what we have now is the if you like, test condition here. So if this, if you like, comparison is true, it executes this line of code. And notice the double, if you like, the full colon marks at the end of the if. These are compulsory. If you don't include them, you'll get an error being flagged up. And similarly on the else here, they are compulsory in your coding. So what will happen here, if this statement is true, if it's true, then this is executed. If this is false, it essentially goes to this statement, or it goes to here, and then it executes this basically statement here. If it's if this condition, if you like, logical condition, is false. So you've got a choice. It gives you a choice of either executing this piece of code or this piece of code. All right. And the nice thing is, yes, you're quite right, Nada. We didn't define X. So as such, this piece of code that you see here would not work. Here, somewhere here, you would need to have a statement X equals, say, 9, something like that. But, so I'm just trying to highlight the if statement as such. So if we just go here now, and let me get my if. So if you look here now, what I've done in this little program here, I've got my X and Y, which is based on my user input, keyboard input, and then I'm doing my if statement here, and then I'm just printing out these two statements. Now you can have one code statement, you can have 1,000 lines of code in this particular code block, okay? But if this condition is true, it will execute the code block that's in here. If this condition is false, it will essentially execute the code block that's in here. So that's if-else statement. You also are able to nest ifs. And here you have this outer if, and you see this vertical line. This is my outer if statement. And here, to nest and basically to show that something belongs to inside my if statement, I use indentation. The code is indented. If I didn't have this indentation, I would, again, it would flag an error. So indentation is important in telling Python which bit of code belongs to where, so to speak. So going back to here, again, this print statement is indented, so it belongs to this first if statement. And similarly here, this if statement is at the same indentation level as the print, telling Python that it belongs to this outer if statement. So if I close that, and here I've just got one statement, print y equals 5. So again, this if statement, if you like, is inside the outer if statement, this outer if statement here. And this is this process of putting if statements inside if statements is called nesting, and you can have n number of nesting levels as are required in your program. So again, you can also use relational and logical operators. So here, as you notice, I've used X and Y. So this now uses the ampersand here sign, which is a logical operator. And if X is bigger than 10 and Y is bigger, sorry, if X is bigger or equal to 10 and Y is bigger or equal to 5, it'll execute this statement. Otherwise, it'll execute this statement. Now, what you can do is also use what's called the if else structure. And this is like daisy chaining or connecting together a whole series of, if you like, logical tests together. So this is the first test. If this is true, it executes this test. If this is false, it goes to this test here, checks this. If this is true, it prints this. If this is false, it sort of goes down to here, checks this. If this is true, it'll print this. If this is false, it goes to the next one, which is the last statement in the if-elif structure. And you can have a whole host of these, if you like, code structures in your programming to do things. So this is really what I was showing here. And again, here are sort of some logical, if you like, or logical conditions that you can use. Equals, two equal signs, not equals, less than or equal to, greater, and greater or equal to. And this, again, is an example of the if-elif statement, a structure that you could use. Now, a typical example of using this type of structure is if you've got a problem like this, you've got student grades, okay, you've got scores, and you want to allocate different grades depending on what scores a student has. This type of problem is ideally suited to an if-elif structure. So you'd have your if statement here. This would be if. This will be an elif, elif, and again this would be an elif, 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 and then else, else structure like that. So that is again this type of problem is ideally suited to one way of dealing with it is using an elif type structure. And as you saw here, if I just run this program, which is in your CS range 1. So I'm going to say here my terminal window 11 and then 12, 22, sorry. And it prints out here traceback, and I've got an error here somewhere in my code because it's got float and int. So it's having a problem because I'm trying to do two different data types, and it gets confused again. That is something you need to be wary of when you're using problem, sorry, when using different data types. Next sort of data structure that we can look at and use in programming is the loop, the for loop. And what we have, we use the for loop when we want to execute a particular block of code a specific number of times. We know this so-called n number. Okay, and what we have is structures like this. So for x in range 5, and what this you saw something similar before to this. So this, if you like, is your loop counter, how many times you execute the loop, and it looks in this array, if you like, your range array, and then it will print out whatever number or the range of numbers that are held, if you like, in your range array. And again, you can specify a range like this of numbers. And here we have indentation, as is mentioned here. And this tells us that all these three statements here, are actually inside the for loop that we have. So again, if we look at, let me just get the, so again, looking at some code, what we have is print something in F in the range of 10, then print this string, which is printing out a string. We've got, if you like, a list of football teams, and again, you've got print out strings, and then here, similar to the idea of nesting ifs, I've got this for loop inside this outer for loop. So if I just, so essentially again, because of the indentation level, this for loop with n equals range, whatever, is inside this outer for loop here, as you can see. So if we run this particular code, which is in this file here, cgs_s_4 type, what we've got is this particular set of outputs that you can see. Print this string, which is here. Print this string. Oops, sorry. It prints. First of all, it prints out the range of numbers from 0 to 9. Then it prints out the character, which is this print statement here, followed by printing the string, which is essentially printing the string. Each letter is on its own line, including the spaces. Then I print the 30 asterisks here. And then here, finally, I'm printing out the list of teams, as you can see. And finally, I've got print *20 z. It is 0. I'm initializing the variable z, and then I'm essentially printing out the final value of z, which is a multiple of m and n, which are the loop counters, m here and n here. And why does it give me 6? Because it looks at this number here, range, and it only goes up to the number 3, because it goes 0, 1, 2, 3. So the final value of m here is 3, and here, again, it only evaluates up to the number 2. So I have the final value of n is 2. So I've got 3 times 2, which gives me essentially 6, the value of 6 here, because of the way that Python works when you have a range of values or an array and its indices. So you've got this type of thing that you can do. And these are some sort of the snippets that I've just executed in the for loop. We also have what's called a while loop, which again, a while loop is essentially used when we don't know when this exit condition or loop happens. So this is loop exit condition. I mean, here I'm actually initializing the loop counter, and here I'm incrementing the loop counter. So it's different than the for loop, as you can see. And again, here I would have my code that needs to be executed. So this is the sort of structure of the while loop. And again, here now is a very simple code snippet. And again here, as in the for loop, as in the if loop, I've got a nested while inside this outer while. So this is my outer while up to here. And then my nested while is in here, is essentially inside this. And it would again execute until these exit conditions were met. And again, notice that I'm incrementing my loop counter here, K, which is this loop counter. Here my M is the loop counter, and I'm incrementing it using this particular bit of code. So if we look at some code snippets here that we have. So this is a bit of code. Now I've changed it somewhat here, and this is a more realistic, if you like, example in this particular file here, which I've shared with you. I've initialized these 2 numbers, and I've used a condition called true for my while loop. And this while loop, which essentially is, as you can see, contains all this code inside it, will execute until this condition turns to false. So, and what I'm doing here is running some code to basically take the user input and add a series of numbers. But if I run this particular code here, I'm going to type in 1 here in my terminal window. 1, press enter, 2, press enter, 3, press enter, and then I'm going to type in Q. And essentially what it's done is it's found the total of 1 plus 2 plus 3. Now, the reason that I used a true statement is that if I wanted to give this program to another user, there would be no way of knowing how many numbers the user would have in their list. All I know is that if they type Q, then that's the end of the list. So this is an example of using a while loop where the condition is true, which is one of the reserved keywords in Python. And again here, when this statement here, what it does is when the input is Q, it breaks, essentially it goes out of the loop and it performs this calculation that you saw here, essentially. So that's one use of while, slightly different as well, using the true, if you like, logical operator. So again, this is the example that we just saw. Now again, we have input and output from Excel files. What you can do is use this particular file, and what happens, I go back here, I'm actually importing the packages that I want to use in my program. Here, I'm using what's called a data frame. I'm assigning this variable to a data frame from pandas here, PD, and it's saying read this Excel file and then print whatever DF is. So if I were to look at this particular file here, which is in my Python. Let me just find this particular file. Oh, here we go. So what I've got here is essentially this file here. Now I've got the backslash. I can actually put it on one line like that to of code. So what I'm doing is it's reading the data file, then it's creating a variable X from my data frame, which is xval, and xval is the column heading of the data in data 002 XLS, and yval is the column heading again for that particular data file that I'm actually using it. Now, the reason I don't have a path before my actual file name is that this particular data file is in my default Python folder, so I can do away with typing in the full path name to that particular file. So here I'm creating two variables here, printing them out, then using here the array, if you like, function from my NumPy package, I can multiply, do, if you like, element-wise multiplication of each of the elements in X and Y arrays, and then I create a data frame, df2, based on the array Z that I've created here, and I've called the column heading points, and here now using again the data frame, the points, which is essentially the name of the data frame, this function toExcel, which essentially writes to the Excel file, and this is the Excel file that I am essentially writing to. So if I go run, and what happens is, here if we look at this is essentially the data in the Excel file data 002. I put it into two lists, if you like. Then Z is the 1 times 6 is 6, 2 times 7 is 14. And essentially now what I've done is created a file, an Excel file in my default directory, and which is, I think, Excel 003. What did I call it? Data 003. And in that particular Excel file, what you have essentially, this is the Excel file. You've basically, this is the index, if you like, in my data frame, and then these are the actual data values that I put into my Excel file. I feel, well, if I want to manipulate that, I can actually delete that. And the only reason that the indices appeared was the fact that I was using a data frame. There are other ways of exporting data from Python to an Excel file where you just export the data. I'm not going to say that. Now, if you just installed Python, etc., what you would need to do in your terminal window is do a pip in install of pandas, and in also, before you try to use the program, do a pip install of numpy to be able to use some of the functionality like this read Excel, to be able to use the data frame, and to be able to use the this array, this here NP array function that we use to do the element-wise multiplication. And that, I think, we are roughly, we've got about 3 minutes of the 1.5 hours remaining. I think it's a good point to terminate. We've not covered all the material. We've got quite a few slides left, but as I said, I think it's a good point to go through. We're roughly speaking, we're about halfway through the all the material, but there's no point in rushing in the material. And you have in the files all the example files to look at arrays, to look at things like things that we would do with arrays, essentially. Just things like finding the inverse, writing functions, and doing a bit of graphics plotting, and essentially finally matplotlib, creating some nice graphics here like this, sine wave, different types of plots that you've got available. So all these files are available to you in the shared folder. Okay, so you can have a look at them in your own time, and if you have questions, please drop me an email. So that, again, this is building a GUI, simple control button here, and a label, and these are called widgets, in fact, in Python. So that's the whole set of stuff. So I'm going to finish now. Shall we access the PDF file at the end? Yeah, you can essentially access the. There are two things that I've shared with you. All the program files that I've used in this presentation to cover the complete presentation in the zipped file. I've also included the Python PowerPoint shown, so you can go through it in your own time. And also there is a PDF file which shows you the process of installing Python and the Visual Code Editor, which is what I'm using. So all those are available to you in the files area of this meeting, and you should be able to download them and run the files. Do you have any other questions? The only thing that I would say to you is at the end, please remember to fill in the if you like, feedback form for this workshop, and hopefully I will see you at 1 o'clock, where there are actually fewer slides to go through in the 1 o'clock presentation. But hopefully you have an idea of the types of things to do and you can do with Python, in a fairly condensed form. Okay. So at this point, there is another session, which is at 1 o'clock, 1 to 2:30, and there I'll actually be concentrating more on two areas: how you can use Python in engineering, and how you can also use Python in what I call basic data analysis. So the focus of the next session is engineering applications of Python and data analysis applications of Python. Okay. When it's completed, when I finish it, you should be able to get hold of the recording in the meeting, I think. If not, I will make it available in the share folder, which you should be able to access. Okay. Okay. Thank you too for your time and your patience. Essentially, the next session is on the next session. Let me see. The next session is in the calendar. The next session is here. It's in the calendar, and you just have to join it. I essentially created a on WCO. Okay, anybody who was there, I've created a invitation for all these people that appear in the appointments slot, and as I said, this begins at 1 p.m. 1.5 hours, and I've put out an invitation to all these people, and this invitation was the invitations went out on Thursday around about 3 p.m. So if you used WCO subsequent to that, I don't think you'd have got an invitation. So that's how I said most people that are registered on WCO would have got an invitation for the next session. Okay. Okay. At this point, it's 5 minutes past the hour. I will say goodbye to everybody. Again, thank you very much for attending, and hopefully I will see you, or some of you, in the next session. Thank you very much, and have a good day.